you to look at what I have on the board. Have you seen this before? Where? Oh, I heard it. You guys are faster than the last class. Where did you say you saw it? Systems of equations, okay? So, systems of equations you learn in algebra. What method would be the best method for solving this system of equations? Which method? I heard it, substitution. So, I know that y is the same as 2x plus 3. So in the second equation, I can replace y with, all right, so I'm going to bring down the x plus 2x plus 3 because that's what y equals 9. Now what can I do? Combine like terms. So x plus 2x, 3x plus 3 equals 9. Keep talking me through it. Subtract 3. 3x equals 6. Therefore, x equals 2. 6 divided by 3 is 2, not 3. All right, so if x is 2 and 2 plus y is 9, what is y? 7. Okay. Parametrics work very close to the same way. Okay? Let's look at a table for parametrics, and then we're going to come back to that systems of equations. All right, I can pick any value for t, so give me a value t that you want to start with. 0? Okay. So when I plug 0 into this equation, what do I get? 1. If I plug 0 into this equation, what do I get? 2. 1, 2. I plotted the order pair 1, 2. I only plotted 1, 2 because I have an x-coordinate grid, and I'm going to explain the other reason in a minute. Give me another value to try. Oh, let's be creative. Come on. Guys, look at what values you have. -1, thank you. So, that gives me 3, 3. So 3, 3 is a point. Okay, give me another one. Now you have to be careful with 7, right? Is that going to fit on my chart? No, because that's going to be 1 minus 14, which is a -13. It only goes to -10. 4, okay. So 1 minus 8 is -7. 2 minus 4 is -2. So -7, -2. There are 3 more slots. Go ahead and fill in your choosing, and we'll discuss it in a moment. All right. So give me some more choices. You like -3. All right, -3 would give me 7. And what else? What's 2 and 5? Thank you. 7, 5. 7, 5. Give me another one. All right, -4. -4 is going to give me 9 and 6. 9 and 6. Okay, can someone give me a positive number? 2. All right, 2 is going to give me -3 and 0. What do you notice? It's linear, okay? Both of my initial equations kind of look linear, right? What we're going to do is we're going to condense the equations down to 1. What you notice is in the last class they asked, well, wait a second, why did you only plot x and y? And I said, well, because I only have an x and y coordinate. Well, that's only part of this story. I can plot only x and y because I did what? What did I do? I plugged in the same exact t value to both equations, keeping it the same. Okay, so let's go back a minute. I did the same thing here. I plugged in this value for x this value for y, which gave me the same variable so that I would consistently plug in the same number. All right? The steps to this, and I skipped a screen, sorry. The steps to this are as follows. You need to get t by itself in the x equation. So the x equation is x equals y minus 2t, correct? Was that the equation I gave you? Okay, so how would I get t by itself? Subtract what? All right, so I have x minus 1 equals negative 2t. Now what do? Divide by negative 2, and that gives me t. All right, what was the second equation? Y equals 2 minus t. So I'm going to write y equals 2 minus what? What am I going to put there? X minus 1 over negative 2. Now I'm going to distribute. The negative gets distributed to what? What part of the fraction? It doesn't matter. But I, for consistency, always distribute it to the numerator. You either distribute it to the numerator or the denominator. Remember, this is like multiplying by a negative 1. Negative 1 over 1 is a negative 1. If you give them both negatives, it becomes a what? Positive 1. That's why you can only distribute it to either the numerator or the denominator. I distribute it to the numerator to keep it consistent, okay? So that gives me y equals 2 minus x plus 1 over a negative 2. Yes? Then y equals 2 plus x over 2 minus 1 half. I just took the negative 2 part of the fraction and I split it into two fractions. Yes? So y equals 3 over 2 plus x over 2. Okay? If I have two wholes and I get rid of a half, what do I have? I have a whole and a half, which is 3 halves. Okay? That's all I did is I combined like terms. I combined like terms to get the 3 over 2. Now I need you to go back in time to algebra. And where did you see this in algebra? Say it again. I saw it with slope. This is what type of equation? Linear equation. Y equals mx plus b. What does this represent in a linear equation? I know rise over run, but that's not rise over run. Where I touch what? What's the vertical axis? Okay, so it's the y-intercept. Okay? And rise over what run is really technically what in math? Slope. Yes, we need to get better with our vocabulary. Slope. Good job. All right? So, I have a y-intercept of 3 halves and a slope of 1 half. Do you agree with that? Okay, so let's go back to our problem. Oh, gee, when I connect the dots, where's my y-intercept? 1.5. Oh, and my dots go up 1 over 2, up 1 over 2. So I was able to condense it to create a single graph. Okay? So you have two problems at the bottom of your page, number 3 and number 4. Can someone repeat the steps before we go? Can someone please repeat the steps before you go? What do? What do we do? Get t by itself in x equation, and then what? then sub into y equation. Okay, so let me ask you this. When you go to put an equation and see the picture in your calculator, what form is it? If I want to put a parabola in, if I want to put an exponential in, what button do I hit? The y equals. So we always want the y equals to stay. That's why we get we get t by itself in the x equation. And it's t that we're getting by itself because both equations contain t. Good? So you were only doing number 3 and number 4. Okay, so let me erase my work so we have room. Let's move this up. Okay, the first equation. I did a swappity swap because I have a whole equals a fraction. So I went with t minus 2 equals 1 over x. And then I did t equals 1 over x minus 2, and I was done with getting t by itself. Oh, sorry, it is plus. Yep, thank you. Good? Remember, when you have a fraction equals a whole, you can just trade out. Or you could have done the whole cross multiply. Now I'm going to plug it into this equation right there. Y equals 4. And in parentheses will be the 1 over x plus 2. So y equals 4 over x plus 8 plus 5. So y equals 4 over x plus 13. And you can leave it like that for now. Question? You had 4x instead of 4 over x. Okay, everyone good? Okay, so you always get x by itself because remember, like when I said before, when you want to go to graph, it's going to be an equation that's y equals, right? So y equals x squared plus 2x minus 7. It's going to be something, if I wanted to look at the graph in my calculator, it's going to be a y equals. Okay? Good? I'm erasing and moving on to the next one. All right. The next one is 6 minus x equals t, or you may have said negative x plus 6 equals t. Either works. Okay, good? All right. So then y equals the square root of 3 parenthesis minus 4. I'm going to plug in. Which one did you guys do? Negative x, so I'll use that one. Negative x plus 6. So y equals the square root of negative 3x plus 18 minus 4. Y equals the square root of negative 3x plus 14. You can leave it there. Problem done. So you would still, no, it wouldn't have been a negative 18. It would have been 18 minus 3x. And then when you subtract 4, it's still 14. Good? Are we good? Can I see some thumbs up, thumbs down? Where are we at? Easy enough? Okay, why? Why the thumb down? Okay, so do you want to see it with this? Okay. So it would be y equals 3 times 6 minus x minus 4. So square root of 18 minus 3x minus 4, which is square root of 14 minus 3x, which is the same. They're the same thing, just different order. Yep. Same thing, just different order. No. What is the rule? What equation do you have to get t by itself in? X. And then plug it into the y because we're going to eventually want to be able to graph that. And to graph it needs to be in y equals form. Good? Everyone good now? Again, one more time. Thumbs up, thumbs down, thumbs to the side. I got some people tuned out. I guess we're watching other videos. Okay, good. All right.